Hey everyone, thanks for coming in and thanks for bearing with us for all the time. Um, so we thought to talk about, first of all, myself, I'm the project lead and CEO of Blockswap Labs, so a small company behind what we're showing here. We are a pizza team of 10 people, right? Just, tackling some of the issue that we think very critical and we are very passionate about it. So we want to talk about why we're doing this, most about like what and how. That's what we can talk about. There's a reason why we're doing this and how long we've been doing this. So, yeah. So why Steakhouse? Vitalik went up on a stage last time, I think in Paris, and he was basically showing what is a critical thing in its sample, like public benefit infrastructure. That was like a few months before. So we've been working for a long time, but just like Vitalik just explains in a very, very good way. You can go and see that video, like why the EIP matters. And everyone was against it, EIP 1559, what the fee market matters, right? A decentralized network need market-based operations. And so you can have more players to come and participate. So if there is a transaction needs to be committed faster, you can pay premium and get up on the queue. In a similar fashion, like anything that you want to have a very permissionless and decentralized network, you need to have this kind of participatorial, on-ramps and very much, demand-based. And that's how the economies are based. So we need to have, these are the things that he mentioned, like L2 scaling, rollups, and the third thing is the easy-to-use stake tooling. That's where we're coming in, right? We are building tooling around Ethereum staking today with the Steakhouse to begin with. Why this is important is when we get the tooling more and more, a decentralized network will get more efficient. So it's like easy mode, right? When we get more tooling, it's easy to use. More people will be able to leverage what's under the hood. So we keep this theory of easy mode, right? Make it easy for user who want to deposit money, make it easier for ecosystem players to want to plug and play with, let it be node runner, let it be an institution who want to deploy the money, let it be a protocol who want to reuse the capital for other things. So how do we create this kind of a very user-focused plumbing? So we work on a user focus. We just want to work backward, not something built today and then say in 2 years it will get adoption. We want to solve some problem that they have today, but at the same time offer all the guarantees of permissionless and decentralization. So what is Steakhouse? Steakhouse is basically a programmable staking layer. When I say programmable staking layer, it's a smart contract suite. It's an immutable smart contract suite. To understand what is an immutable smart contract is, you don't really have to worry about the team behind it or who's going to manage it. As long as Ethereum blockchain is there, it will be there. So just serve the purpose that it's intended by the protocol to the users forever. And the best example is their Uniswap, right? Once you still have the V1 and V2 and V3, you can use any of those in the Uniswap because it's immutable every version. Similarly, this is immutable. So it's a registry, it's a dual factor registry between Ethereum deposit contract, where the gateway to send ETH to consensus layer or the beacon chain. And it also do another thing. It will allow user to abstract that deposited ETH into a liquid token back to Ethereum. So that's like, bringing home and whatever the money that you send there, bring it back and reuse it. I mean, it's a really good concept, but it's not that easy. It comes with consequence, right? Because the money is on another chain, but you need to keep the counting intact. So we keep this dual factor registry between beacon chain and Ethereum, so the DeFi protocols don't really have to do the heavy lifting. What's happening on staked ETH? Who is behind that staked ETH running a node? All those kind of thorny questions, right? Or is there a DAO that is managing all the keys, what's happened if there is a flash loan is going to, manipulate the DAO, or what is the reward rates. If a smart contract can get all this data from on-chain, then it can do the job. You don't really need anyone in between. You don't need any theatrics. You don't need any charade. Just math, right? So how do we get this accounting in very deterministic fashion? So one thing to remember, always protect a normal user. That's very important, right? So you need to work from a very risk-averse, that is like low-risk, mainstream users. Those are the retail users who are going to put the money, protect their money, and then you have this very small number of very advanced users, very crypto-savvy, degen, whatever you call. They want to have higher yield and things like that. They're more risk-prone. They are very strategy-driven. Well, they can take the risk. So you always need this kind of two set of users. So always scatter the both, but at the same time, you don't really need to be a pyramid scheme. You don't need to reinvent the wheel, how the incentives will drive your 6-month or 8-month timeline, rather than use a cryptoeconomics incentive, reuse a blockchain, because that's the best incentives layer that you got it today. And Ethereum is one of the best. That's why it is, you can just basically fork a Go ETH and have Ethereum network, but ETH is an asset that is a network that's being kept by a large number of people. So that's why it has a value. It's a community. It's a wealth of community. So what Stakehouse is not today, or it will never be, Stakehouse is not a token. So it's a protocol. We're not handing out a token and say this token has a value. And there's a peg and you can go and you reuse it. There's a token that you mint from the protocol, just like, think it like USDT and MakerDAO, right? Maker has a DAI, and then it just gives you a DAI and just keep all this, the peg and everything. But USDT has been issued by someone. So there is no centralized issuer here who can freeze your money and who can manipulate things. And that's very important. If it is a token, then you basically give your asset to the token issuer. It's not a staking service per se, or a commission agent, or a custodian. So these three are very interdependent, even though we think independent, but it's very interdependent. Like staking services are really a good part of ecosystem. They're providing the service, but the way the proof of stake networks operates is the security derived from what is at stake. So what is at stake here is the money. There's nothing else at stake, right? The security is really following the ETH at stake. So if your ETH is at stake, then a service provider cannot guarantee that. I mean, he can guarantee some uptime and things like that. So we don't deal with the services. We cannot touch the money. When I say we, the protocol can never freeze the money, because the protocol is just acting on behalf of the user. So there's no commission here. You don't touch the money. And also you don't custody the asset. It's self-custodied, but it's programmatic. So you don't really have to worry about it. Once it's been locked, it's locked. No one can take it away. What that means is it's seizure resistant and censorship resistant, right? And the other two things are, it's immutable, as I said, and we don't use any oracle. There's no pooling. There is no bridge, nothing whatsoever, right? So let's say a retail, I'm just using some names here, institution, but that doesn't mean they're working with us, to be very clear. If Coinbase, Kraken, Binance, these are familiar names that you have at all these exchanges. If they have derivatives, DETH and slot tokens, like if they have staked ETH, put it through Stakehouse, and they have this kind of, let's say, 2 billion, 3 billion, these are big guys, right? They can have as many stake, they do, and they can provide that DETH to their users. And if they bring it to ETH, and someone actually bought that DETH from Coinbase and they're taking it, every DETH is coming through Stakehouse is fungible. So this is very important, because there is no mixing. As Vincent was explaining here before, it's a registry model tracked to a particular BLS key validator, but it's a cash in circulation DETH is fungible across. So this is a big problem in the proof of stake network. It's like it's a very zero-sum game, right? You know, you have X number of liquid stake and the other guy. So what we do is like we allow people to spin up their own liquid staking network and give a name. So in crypto, giving a name is like giving a ticker, right? So you can call that as you know, Matt or S, you know, DAP or S, you know, any name that you want to. But that will actually get you the inventory of how many validators that you hold, what is the rate and everything. Everything is permissionless, so everyone can see that, what's the rate. So the thing it is, when more and more people coming and making liquid stake using Stakehouse, existing users are benefiting. They're not getting diluted, which is normally happens. So if you go to any liquid staking today, they have like 4.7% ETH, but it's 3.5. We are, you know, socialized, though. We are diluting others. So it's someone is coming at your cost. That's not happening here. There is no mixing of assets. It's not a collective investment per se. So retail and institution can sit together. That's not possible. So today, because it's pooling, everything is pooled. The first thing that you do is like you spend your money, you give that permission to the smart contract. Here, you can take to an index, you can take to another chain, but it's your asset. When you are burning, it's actually burning to your asset. So this is a new thing. Yeah, it says about 40%. That's, you know, we put up a tweet about why it is. Let's say standard model of today, the making ETH stake liquid is through synthetics. Synthetics are, if you don't know, it's an IOU. Like, you know, you give me your token, I'm going to mint a token immediately for you, even before it is staked. So you have no clue where that ETH, which validator is went to, because, you know, it's not stake derivative, it's not derived, it's a synthetic, it's minted and handed to you immediately. And then it's an IOU, it's a promissory note that I'm going to give you back ETH someday, which is good. You know, this is really good thing to begin with. But the problem is it get diluted. So mostly about 4.7 is today's yield, about 3.59 is the diluted yield. Normally get it because more people coming in, Ethereum has this queue. So if you put stake today, it's about 2 weeks now, it's going to get more and more higher, the queue. So you basically paying your rewards for the new guys coming in. And if there's $1 billion coming in, good luck. It's like yield farming, right? You just get diluted. And then on top of that, they charge you 10% on the commission, on the rewards generated from your money. So it's like you're already diluting, but here the DETH will say that you have 32 ETH in your validator, and the validator can only mint 24 ETH, DETH, so it's 24 DETH for 32 ETH. So that's 25% more, but there is no dilution, and also there is no commission. So it's about 40% more rewards for anything else out there today with, if you go down this route, and you only have to do is like do a couple of clicks, and you have the asset. That's very important. You own the asset, you have the key, and that's permissionless. So one of the key primitive when we made this, the solution is, it's deriving between two things, common interest and controlling interest. So what is this jargon is common interest and controlling interest? Common interest, we explained the system, the common interest protocol before, but the key primitive is, stake houses are a collective of validators, and if you are having a common interest, put it simple, we can disagree on many things, but you know, we can agree on something. And we all agree on something, not to die today, so we can live tomorrow, right? There's no problem with that, no matter where you're from. So the common interest is like not to get wrecked. So if you get wrecked, there's this kind of redemption rate and mechanism is in play for the slow tokens. And the controlling interest is if you keep that common interest at certain layer, so it's just layer, it's not like one layer. Houses are collection of validators. You can have bundles of collection of validators grouped into together. So you can have like brands and kind of like, you know, how do you create portfolios, right? You can have 20% from one company, 30% from one company, but you can track how that is performing. So that's the controlling interest of the validator, the managing, right, where you can make more money from the gas or, you know, transaction ordering and things like that. It performs better if you keep your common interest intact. So that's a carrot and stick, right? So that's the crypto economics. And another thing is, like here I explained to you earlier, the DETH is more of retail, so you don't really have to buy, you don't really have to worry about how to stake, what is a node, what's a validator, what's a BLS key. Just go and get a DETH from Uniswap, and you have it. It's risk averse. Like, you don't really have to worry. It's the DETH is always trailed to a validator, so you can always redeem it. That's a redemption guarantee. That's risk averse. Like, you know, more and more people are in that category. But then the other one is like the protecting that DETH is the slow token holders have an unlimited payment. So every validator that you're adding today to the Ethereum network is like one-time cost. You keep it intact, you can just earn as much as yield from, you know, Ethereum settlement. You know, this is a network that settled at more than $1 trillion in last year. There's a lot of money going on, and there's a lot of protocols happening. So, but that is not possible today because miners are like behind the scene. But this, when it becomes programmable, certain aspects are getting more interesting for protocols who want to have, you know, better block time, and also, like, you know, better guarantees that their users will not get wrecked from some kind of attacks, you know, open mempool to get some kind of syndication things and things like that. So that's very interesting, because in consensus layer, when the merge comes, it is going to be 12 seconds, 12 second, 12 second, 12 second block time, and there's no ungle blocks. There's no, you know, 2-3 blocks happening. It's just single block, 12 seconds. So some of the milliseconds are more valuable than today. Today it's very probabilistic. You don't know when a block is mining, but that's all going to be shifted come merge. So you really need to pay these validators if you want to get included in that. So that's when it is getting tokenized, it's really perpetual forever. And, you know, the rest of things that we say in atomic redeemability is like the same thing of the deterministic guarantee. The smart contracts can know your DETH, this belongs to a certain validator or a group of validators. There's an atomic dependency between the derivative and the underlying asset on another chain, rather than we have 2 billion assets in this pool, we're going to give you 70% on my Alice token or whatever the token that I created out of thin air, and, you know, you can have 16% yield or 18% yield and then sell. I mean, that's artificial peg, how long you can go with that. And someone is really going to sell? You know, financial markets are really good at making call option and put option, right? If there's a really good put option, like for 20% peg is off, you're wrecked. All the users, nobody's going to sell that, you know, buy that synthetic anymore. So the artificial peg is like, it's I don't know, it could be like banana republics from dictators, like everything is good up until, you know, that day comes. The trustless accounting and on-chain public verifiability is a very key for any protocol out there. So a user, when I say user, it could be like a protocol on behalf of a user, can verify from an on-chain data, not from a third party, from on-chain data. When I say on-chain is like from a node data that is kept in sync by a lot of nodes. So we want to have this public verifiability from the node data. That's very important for us. And how do we make this kind of, the whole structure of Ethereum securities belongs to this decentralized network, right? So there are like key components. Who playing what? Like we talked about Ethereum, talk about this solo staker. Why is it important? Because a person who wants to participate in the system, they should be able to do that without going through, like, you know, a class 2 weeks or 3 weeks. So the packages like Ethereum or, you know, packaging and hardwares like DAppNode, this make that easy to run a node. You have this kind of node in Fura and Alchemy, they're all really great, but it would be better if we have more and more machines are syncing the same database and keeping it intact. So, you know, Ethereum has this kind of a very interesting culture of multi-client diversity. So if you want to get a lot of clients to be deployed by a lot of people, what do you need to do? You need to encourage users to have a commercial reason to, you know, engage with this kind of decentralized network. So everything goes with the crypto economics, right? You you perform better, more and more people participate in the network. So then the other people in, as a infrastructure layer will also benefit. So if you want to have more solo stakings, you need to provide them a route for profitability in the long run, because the opportunity cost is there. So we do that by default. We support all the solo staking and the node runners. And one thing to understand is, if you haven't provided an exit door, do not enter in that room. That's the one rule in DeFi. If there is no rage quit option, if you cannot burn your token and get your asset back, don't put your money whatsoever. All right? Regardless what they say, 24/7, you should be able to do that. So the rage quit, so even Ethereum takes that seriously, you can voluntarily exit, validator today, and you can sit there. Okay, the withdrawal comes later, but you're not putting your money at stake anymore. That's more important. So you need to have that voluntary exit built in if you're doing a derivative, right? That is there. That's a rage quit mechanism there. You can literally remove your validator. You're not part of this game anymore. I don't want to. Because this is very important for global settlement. If something happens wrong, just go away. You can just exit. So right to exit is a very key. Right. So yeah, it's a bit of a vanity metrics, but again, it's not a copy paste or fork or anything. It's about 10,000 lines of code that's been audited for the core contracts, but all the toolings and SDKs and everything built. So custom code is 100,000 lines of code that we've written on this. Again, we're not 100 people, we're only 10 people, so small team, so something we want to talk. So why are we doing this? Is like, things I said, mostly, we want to create a better world, not in the sense of creating better solution what we have today, but we are solving some non-existing problems. That means when we creating solution, there's no World War III, but Ethereum is World War III resistant, right? So you need to think ahead. What are the scenarios can come if everything goes down? So we need to have this kind of things baked in if you want to do a permissionless protocol. So we want to make sure every accounting mechanism in the protocols actually comes on accountability. If there is no accountability, just tracking assets over there, it doesn't really work. Someone has to have some accountability to keep that intact, because the smart contracts are very dumb contracts. They don't really know what's happening outside. There is no oracle here, so someone has to report the balances. So the best way look at it is think about a Uniswap. Again, I'm using Uniswap just for example because everyone knows what it is. You have, I don't know, 100 forks or 200 forks of Uniswap in different chain. And how many of them actually really provide you this kind of a really good price oracle? Not many, because the volume is needed. So when the mechanism-based softwares are really good, when you have more liquidity, and to have more and more people use it, it really performs better than the traditional system. Since this is a cross-chain protocol from the ground up, all the DETH that you're using is in consensus layer. That's a different chain. So by default, it's a ETH in two chains. But you can also take DETH from Ethereum to any rollup, Arbitrum or Optimism, or even to an EVM chain or to Polkadot or anything, if there's an adapter that we deployed. So the caveat, there should be an adapter that we deployed to understand this in a cross-chain mechanism. So there is no bridge, but there is a deterministic proof of where the accounting is happening. So this is provided by the registry contracts that we came up with. And that's we talked in length on the last sessions, what the registry contract, what the key properties, why we're doing formal verification, what are the things that we deployed, and what are the techniques that we're using it. Those things actually stands its ground. So the registry contracts are the new thing that we brought in to make sure this multi-chain composability a reality today. So every cross-chain is kind of a Mexican standoff today. You give your asset to another custodian and you go another chain and you mint a synthetic. Rather here, a user is just going from one chain to another chain. It's not very difficult. You have enough dApps go to your right-hand corner, just click Ethereum, Polygon, Arbitrum, Optimism, just on a click on a MetaMask. You're just hopping from one network to another network. So we are already in this kind of a system where the node providers, service providers all provide this kind of tooling. So why not a user can do that without having an intermediary? That's the key part. So, this is where very important, the node runners. So we can cross-check. So, the best way to look at it is, sorry about that. Oh, this is it. So, oh yeah. So if you look at here, it basically takes publicly verifiable thing into, it cross-check once Alice is coming and coming back to the deposit router, that's another contract set, and submitting her data, just cross-check through different nodes. And that different nodes could be one of her node information, and one from that node, one from Infura, one from Alchemy, one from anywhere. So if we have more and more nodes, a diversity of nodes that we can ping, publicly verifiable, and it will all give you the same data point. But today, the centralized services are not really that great. We came across a lot of issues on the syncing. They give you like 2 or 3 instances, different data. That's not possible because there's issues. But you need this kind of solo networks, human-centric decentralization, everyone taking care of themselves, and you can let them into this kind of verification network where they are also incentivized to keep it. So that's very important. Going ahead, like protocols like Stakehouse or any other protocols who basically want to be sustainable and for long term, they will go for this kind of permissionless nature rather than, and it also helped them because the operating cost is near zero here. That's very important for the companies to exist. For us, once we deploy the contract, we don't really have to maintain the contract. It just worked like charm. We can go away and then it just worked. And anyone can become any of this part. And that's the benefit of this kind of architectures. So human-centric decentralization, that's something mostly overlooked. People think that you need to have, you need to go and put like $1,000 handout to them and say like, why don't you do this? You can get $5,000, $10,000. You don't really have to do that. People are really passionate. When we started the 60-second staking, so Ethereum today, if you want to stake, it's hard. I mean, it's a fact. But we just bought the tooling and made the UI and everything. It only takes about 60 seconds to go from your MetaMask to get your validator node up and running. And it's true. When they see that, okay, I don't really have to learn how the node works. No. There are toolings like SSV in other networks. You can simply drag and drop. They will run it for you. But your money is your money. You can build the derivative. Another 30 seconds, you can mint the derivative. And you do whatever you want to do. Your money is safe. So that is like 0 to 1 in 60 seconds. That's a big thing from the best tooling out there from 2 days. Spending half an hour is very difficult. So if you just make that travel time very shorter, that's very good. So this is how we trying to combine the effect of the tooling and smart contracts very fast, and also at the same time to be very beneficial for the other ecosystem players, right? So they can get more people. You can just go and click a DAppNode website, download it, or Ethereum, and it's just like over the air updates. Your packages are updated automatically, so you don't really have to worry. These are communities are very, very vigilant, but at the same time, they don't really have to look at each other. This is updated all the time, and all they need to do is plug into internet. Boom, it's working. Their money, their keys, but they're also running the nodes, so you don't really have to worry about it. So this will actually get more and more wider decentralized network. And the good thing here is you're using ETH for a greater cost, as the last presentation. So you can have packages built for other protocols on top of this. So ETH will basically do the heavy lifting from the commercial perspective, but the protocols can reuse it for RPC endpoints towards like a group of DApp nodes, a group of Ethereum node runners, and they can get this kind of good data. At the same time, you can use a centralized, but there's always this cross verification helps. Yeah, exactly. So this is something that we talked in the morning, common interest protocol, the cryptographic primitives. So there is always permissionlessness is like you can make money, you can lose money. That's one part, but it's more about continuity. You put your money, and then what happens if you have a piece of a validator that has been abandoned by someone? Or even if you run a validator, if you're away in a beach and you want to immediately get the signing key, the validator signing key, how can you recover that? You need to have a trustless method to do this kind of recovery, and that's what we enable through the common interest protocol through the DKG system. So we show that earlier. You can, if you were not here, you can basically go and watch it in YouTube later on how we do that. So the permissionless immutable, not only only the contract level, but it's also on the off-chain level. So it's truly universal at the day one, and anyone can use it. And I said, don't join the system if you don't really have an exit door. But also very important, if you really put your money based on trust, it doesn't really work, because the trust is a very vanilla, superficial word, depends on many things. So we need to have more and very objective world where the rule-based, where we can enforce in the smart contracts. So the permissionless world will basically allow you to take back your money if you don't really like it. That's the ultimate freedom. So that's all about my vanity talk, but happy to take any questions if you have. But in general, that you're being here, so thank you for coming in and continue the presentation. But still, if you have any questions, I'm really happy to take it. Great.